have this privilege and opportunity to introduce myself. Myself is Swajit Nayak. I represent an organization called Great Analytics India Pvt. So today we will be talking about the cluster analysis. Right. So before getting started, let me give you a brief foundation or introduction of the cluster analysis. Uh, the cluster analysis is a very popular and widely used algorithm which comes from the unsupervised learning family of algorithms, right? So unsupervised learning because there is no particular dependent or outcome variable, right? So if in absence of a dependent or outcome variable, it becomes the unsupervised learning. We do not have a supervisor or a guide to for our analysis. What is broadly the purpose of the cluster analysis? The cluster analysis, the purpose is which should structure the homogeneous or the similarities within the groups, right? It could be cases or it could be rows or it could be the variables. Variables mean the features. We are going to experience that. And within the heterogeneous between, right? So the distance between the groups, right? So that is the main purpose of the cluster analysis. And what are the typical problem we approach and solve during the by using the cluster analysis? We wanted to develop a problem of the taxonomies. What do you mean by the taxonomies? Broadly, we cluster these groups on basis of the homogeneity to develop a problem of classification. The taxonomies is also known as the classification problem, right? So we develop a problem of prediction classification problem. So let's get started. So during this course of the session, we will be using a no coding, low coding tool called Statistica, which happens to be one of the leader in data science, machine learning, artificial intelligence as a commercial platform, which has been named by the Gartner, which is a very credible international rating agency. So I have opened the Statistica tool. As I said, it's a no coding, low coding tool. In order to perform this unsupervised learning, I will not writing a single line of the code to perform the basic to the advanced operation. Statistica software provides hundreds of the inbuilt data for the purpose of the self-learning. So I would pick up a data from the Statistica uh, called cars.star. I can view the volume of the data on the top. The name of the data set is the cars, right? That the data set, the volume of the car data set is the 5 variables. The V denotes to the column, or primarily you can also, this is known as the feature, descriptors, variable, different name, it comes in the different domain, right? And the 22 C cases, right? So these rows or the observation denotes to the cases, right? So here I can see in the features, we have, if wanted to have a uh, full description of the features, we can go to data, and under the data, I can go to the all specification. Under the all specification, I can see the price described as approximate price, acceleration, braking, braking denotes to braking from 18 miles per hour, handling, road or holding index, and mileage, mile per gallon. That is the description of the data. But what I observe here, right, because all these, the pricing comes in the negative, so it cannot be. So this is the standardized data, right? And as under the data also, we have the feature like standardized. Suppose you have the experience of getting a non-standardized data, you can do the standardized in pick up a button from the data, from the featured data from the standardized. So here we can see, because there are different make of cars has been listed in in rows, right? And as we said, because the one of the main purpose of the analysis, given this data can be taxonomy for automobiles included in the study to be developed, right? And also these popular unsupervised machine learning algorithm widely used to solve one of the very critical applications called market segmentation, right? So here, what the market segmentation we got in the rows, we have the different type of the cars. In column, we have the features of the car. So we wanted to cluster on the basis of the similarities in the features we have, and we develop a taxonomy problem like classification. So we would cluster these groups in form of like the economic car, sedan car, luxury car, right? So depending on our business judgment. So this is the recent hypothesis we have created. We will segment these cars in the three categories: economy, sedan, and luxury. So let's get started with the cluster. I go to statistics, because as I said, cluster is a part of the unsupervised machine learning family. So under the statistics, we have something, a defined tab for the multivariate exploratory techniques. So that multivariate exploratory techniques, like it covers cluster analysis, vector analysis, principal component and classification, canonical analysis, reliability item analysis, classification trees, correspondence analysis, multidimensional scaling, discriminant analysis, general discriminant analysis. But currently we have uh, something, a task in hand. We have to deal with the market segmentation on a given data set, right? So I again drop down the clusters. So different type of the cluster techniques are available in Statistica: joining tree clustering, k-means clustering, two-way joining clustering, right? So let's start with the joining tree clustering, right? So here, like whenever you deal with this no coding, low coding tool Statistica, always you come across with the two tab, quick and the advanced. The quick gives the basic features. If I explore the advanced, I get much more advanced features. So here it is asking me the input file. So if I drop down, I do have the two options: raw data, distance matrix. In the cluster analysis, because that is also one of the advantage of the cluster analysis is to deal with both the variables column as well as the cases. So currently we'll be dealing with the scores or the cases. So we have different amalgamation linkage. So we have single linkage, complete linkage, unweighted pair group average, weighted pair group average, unweighted pair group coverage, so on and so forth. And the what matters. So let's go with the default one, single linkage. Distance matches. This is the most important part of the cluster analysis. So, Statistica support the squared equilibrium distance, city block Manhattan distance, shape distance, power sum, percent disagreement, and Pearson. But widely used the algorithm is the equilibrium distance. Let's go with this selection, right? So I will take all these features, right? There are multiple ways I can select the features, right? So this is the output I got, number of variables or number of features I have 5, number of cases I have 22, joining of cases, right? We have missing data where, like in case of missing data, the data set consists, I would have got an alert. Here I got under the quick, the horizontal hierarchical tree plot and the vertical icicle plot. So let's explore this, right? So on the basis of the simple linkage, what we had selected, the distance, we had selected the Euclidean distance, and this is what the graph is an output. This graph is very, very popular graph, is also known as the dendrogram, right? As you may be aware, all the numerical analysis in Statistica are always complemented with the graphical representation or visualization. So you get this graph, which is dendrogram. In addition to this structure of the graph, the horizontal structure, another structure is supported by the Statistica also, the vertical plot. In addition to the graphical methods, we have the numerical output also. So that gives you all the distance calculated on the basis of the Euclidean distance. So very well on the basis of the distance, you can figure it out the clusters among the car. I can get the descriptive statistics. I get again the distance matrix. Again, I get on basis of the distance metric, I can see the various cluster here. If I see the rows number 1 on the basis of the distance metric, the Chrysler and the Dodge has been clustered. So the different output I get under this from the. In addition to that, as Statistica support the 3 type of widely used clustering technique, now we will be dealing with the k-mean clustering. What do you mean by the k-mean clustering? What is the situation we apply the k-mean clustering? You get all these like the distance and everything, right? So it will be, yeah. So what is the situation we apply the k-mean clustering? Suppose that you already have a hypothesis concerning the number of clusters in your cases or variables. You may want to tell the computer to form exactly 3 clusters, right? So already we have developed a hypothesis here because we have a task with hand. We wanted to segment the car in 3 groups or clusters, right? Economy, sedan, and the luxury. So already we have a hypothesis. So this data set is eligible for your k-mean clustering. So I go to the cluster, start new, k-means clustering. Okay. Again, like I go to the advanced to have the more features, right? So I get the cases, right? Number of clusters. Already we have a hypothesis. We wanted to develop the 3 clusters: economy, sedan, and luxury. Fine. So let's go with these selection. We select all the variables. We can do another way, like suppose I put the shift and star, it will select all the variables, right? So let's explore what all the output it is given. Summary of clusters, means and Euclidean distance, right? So since we have selected, we wanted to build three clusters. I got the three clusters, right? So I got the distance also, right? Heterogeneous between, what is the distance between cluster 1, cluster 2, cluster 3. I get the analysis of variance, the ANOVA table. Under that ANOVA table, I get between sum of square, degree of freedom, within sum of square, degree of freedom, FP. So what I can observe here, right, under the by getting the p value less than 0.05, I can determine which of the variables or features contribute maximum in identification or different type of the car. So here I can see all the variables are important to build a cluster. Graph of means that is a very like interesting plot, right? So here you can cluster, like suppose you see, if I see the let's see the pricing, because pricing is one of the most deterministic factor of this thing. So the what I can see, the cluster 2 is the maximum price, right? Cluster 2 is the maximum price, and your cluster 3 is the minimum pricing, right? So let's figure it out when it will form the cluster. We can keep in mind descriptive statistics for each clusters. Members of each cluster and distances. So I get the individual, the grouping, or the members of the clusters. So one has been formed, like the Acura, Buick, Chrysler, Dodge, Honda, right? So this is the cluster 1. This is the cluster 2, where we have the Audi, BMW, Corvette, Ford. Very well, we could figure it out from the mean graph. The cluster 2, which is the highest in the pricing, but that is the luxury car, right? Cluster 3, we see the Eagle and Isuzu. Eagle and Isuzu is the economic car, right? Because the price was the lowest. So that is the economic car. So here I can see on the different cars, the cluster has been given, right? If I go to the variable 7, I get the different cluster. So let me explain. So what I could understand, the one we can, the one we can name it because sedan one. My luxury, it is totally depends the two, and my economy car is the 3, because I could observe from my mean plot, right? The highest pricing was with the cluster 2, and the lowest pricing was the cluster 3. Okay. So here I got these clustered here, right? So the Acura, on the basis of the matrix I got the cluster here, right? So here, since one of our main objective for a cluster analysis to develop a prediction classification problem, right? And we are solving a market segmentation problem here. So at the moment I get a new customer, right? The new customer I get in the name of the case 23, right? And I asked the customer, what is your preference? You are looking for the pricing. If the customer say, no, I am looking for some kind of the economic car and this is my price range, I'm little price sensitive. So very well, I can take them to the car like EC2, right? And Eagle. These are the economy car segment. So this is the way we perform the cluster analysis, which is one of the unsupervised learning family of algorithm. Thank you. Thank you very much for your time and patience.
Thank you, sir.
Thank you, sir.
Give me one.